Hey, hello and welcome to all my dear students. Let us start another chapter in Maths 2 called as Trigonometry. Now an extension of this chapter will be there for your 10th standard also. Before we start the topic, now we have a few more practice sets to be completed. So I'll be posting the videos in between. I request you all to please subscribe to the channel and press the bell icon so that whenever I post a video, you get the notification soon and you can prepare for the exams. Without wasting much time, let us get into this interesting chapter called as Trigonometry. It's not that trigonometry is introduced recently. No, trigonometry was introduced in the year that is from 3rd century BC. Through geometry, we are in touch with trigonometry. Trigonometry is widely used in astronomical studies. Okay, because I have heard people, those who don't know maths, making fun of trigonometry. I don't know where to use it in my practical life. Trigonometry is used in geometry for astronomical studies. It is used in astronomical studies. If I talk about some other use, it is again used in celestial mechanics. Okay, it is used in celestial mechanics or celestial mechanics. It is the branch called as trigonometry, which is a branch of mathematics, is again used in navigation to just to find out the distance between ship and a particular construction or a lighthouse. It is used to measure the height of a tall building like Burj Khalifa, the tallest building. Okay, or it can be used to determine the height of a tree. Rather than sitting on top of the tree and using a rope to measure the height, we can measure the height of tall constructions by applying trigonometry. Okay, so these are some uses of trigonometry. Now, if I go to the meaning of the words trigonometry, again, trigono, that is trigonon. It is actually trigonon. It is a Greek word. Trigonon is a Greek word and it means trigon. Trigonon means it is a three-sided figure. It is a triangle. Trigonon means it is a triangle. And metron, as we know, metron stands for to measure something. It is to measure something. So what is trigonometry? Trigonometry is measurement of three sides of a triangle. That is trigonometry. So if somebody asks you what is trigonometry, you can state it as trigonometry is a branch of maths. Trigonometry is a branch of mathematics that studies, please mention this statement in your book. Trigonometry is a branch of mathematics that studies the relationship between, length of the sides, between lengths of sides and angles of triangle This is trigonometry in simple sense. It is a branch of mathematics that studies relationship between length of sides and angles of triangle. And trigonometry is related to, it has its most of basic concepts related to a right angled triangle. So we will be taking right angled triangle to know more about trigonometry. So let's get started. I want you to write this statement in your book. You can also mention the uses which I just specified. It is used for astronomical studies. It is used for celestial mechanics, navigation, surveying. All these are the various uses. Surveying also you can add. To measure the height of a tree, to measure the height of a tall building. Okay, I mentioned about the tallest building, Burj Khalifa. Where is it? It is situated in Dubai. So these are some of the uses of trigonometry. So somebody asks you, where is trigonometry used? What is the use of trigonometry? Yes, to know trigonometry, you should know mathematics. Okay. Told you trigonometry is studied with the help of a right angled triangle. So I have taken a right angled triangle. We will show this as 90 degree. We'll take the name of the triangle as ABC. Trigonometry is the relationship between the measure, that is the length of the sides of right angled triangle, and the angle. There's a relationship between sides and angle. Now, when I take angle B as 90 degree, we have learnt about triangles. We have come from the basics of triangle. We know that the other two angles, if you add, it will be 90. That is, the other two angles is acute angle. They both are acute angles. So, angle A, angle C, both are acute angles. Now, out of these two acute angles, any one angle, I may take it as theta. Theta is the angular measure of the acute angle. This angle C, instead of calling angle C, I will call it as theta. That's it. Nothing more to add on to this. Okay. Angle C I have taken as theta. This sign we call it as theta. Okay. It can be alpha, beta, any way you can use, but for the time being I am using theta. Now we will consider the different trigonometric ratios or different parts of this right angle triangle through trigonometry we will learn. The first thing, that is, if I ask you which is the side opposite to angle B. Angle B is this angle. The side opposite is AC. And this AC is nothing but the hypotenuse of right angle triangle ABC. Whenever you see right angle triangle, you always remember Pythagoras. Okay? Pythagoras theorem or hypotenuse side test. Both are one and the same. What is Pythagoras theorem? The square of the hypotenuse is equal to square of the sum of the other two sides. That is, AC square is equal to AB square plus BC square. This is Pythagoras theorem. Now let us learn about trigonometry. In trigonometry, any one acute angle I took as theta. Now for this angle theta, I will write down, or we will learn the various trigonometric ratios. Which are the trigonometric ratios that you are going to learn? There are trigonometric ratios like sine, then there is cos, then this is called as cosine, but in short we will learn it as cos. Then you have tangent, the short form we will learn as tan. Sine, cosine, tangent. Then you have the opposite of sine, that is cosecant. Then you have secant, and then we have cotangent. These are the various trigonometric ratios. Now out of this, we will be covering up sine, cosine and tangent in 9th standard. Sine, cosine and tangent. In short, the short form of sine, cosine and tangent we will be writing as sin, sine for cosine we will write cos, for tangent we will write tan. For cosecant it is cosec, for secant it is sec, only this much part. Okay, and for cotangent we will take only cot. For our 9th standard we have to learn these three ratios. Now let me discuss with you what is sine theta. Okay, as I told you, one acute angle I will consider. That angle I have taken as theta. Now you have to learn this formula. Sine theta is nothing but, I told you, trigonometric ratio. So it is something upon something. Trigonometric ratio. Trigonometric ratio means one quantity upon another quantity. So it is a ratio. So here sine theta means, the formula is opposite side of angle theta. That is opposite side of angle theta upon hypotenuse. As we know, for this triangle, as we know, hypotenuse will be one and only one. What is the name of the hypotenuse? Hypotenuse will always be AC for this triangle. So no doubt in that, hypotenuse is AC. Now, as I told you, I'll write the formula once again here. Sin theta is equal to, say the formula along with me, write in your book, opposite side of angle theta upon hypotenuse, opposite side of angle theta upon hypotenuse. Now you look at theta, which is the opposite side to theta. Opposite side is AB. So in place of opposite side, you will write AB upon, what is the name of the hypotenuse? Hypotenuse is not going to change, it is AC. Okay, so sin theta is AB upon AC. From this triangle, the value of sin theta is AB upon AC. Learn the first formula. This is the first formula. Now let us learn the second trigonometric ratio. As I told you, after sin, cos. Cos theta is equal to, for cos theta, the formula is adjacent side of angle theta, adjacent side of angle theta. Now for this theta, adjacent side upon hypotenuse. Now, hypotenuse will remain the same. Repeat, cos theta is equal to adjacent side of angle theta upon hypotenuse. Now this angle theta's adjacent side means neighboring side, aju baju. So here this theta has two neighboring side. That is, one is AC and the other is BC. No? Neighbor means baju wala, neighbor. Now out of AC and BC, side AC is the hypotenuse. AC is the hypotenuse. So you will not consider hypotenuse as adjacent side. No. So which is the adjacent side remaining for theta? It is nothing but BC. So remember, hypotenuse you will never consider it as adjacent side. Which is the adjacent side of theta? BC. So it is BC upon hypotenuse is AC. Hypotenuse is the same. Understood? Now let us learn the third trigonometric ratio, that is tangent or tan theta. Tan theta is nothing but opposite side of angle theta to upon adjacent side of angle theta. Okay, opposite side of angle theta upon adjacent side of angle theta. So if you see this theta, the opposite side of angle theta is AB, as we discussed. So this will be AB upon adjacent side of theta. Adjacent side is BC. Hypotenuse you will not take as adjacent side. So adjacent side is BC. So this is AB upon BC is tan theta. Now here length of the sides is not given. Suppose they had given you BC is 4, AB is 2. Then we will get the ratio, no? What I wrote, AB upon BC. So how much is AB? AB is 2. So here you would have substituted 2 upon BC. You got 4. Okay. So then you will cancel 2 ones are 2 twos are. So the ratio is coming to be 1:2. Here the length of the sides was not specified. So you wrote it in the form of sides. When the lengths are given, you will get a proper ratio. I hope you all understood trigonometric ratios. For 9th standard, you just have to learn sin theta, opposite side upon hypotenuse, cos theta, adjacent side upon hypotenuse, and tan theta, opposite side upon adjacent side. If you want, I'll just give you a clue to remember it. Sin is opposite upon adjacent. Cos is adjacent upon hypotenuse. Okay. Hypotenuse. Sorry. Opposite upon hypotenuse, adjacent upon hypotenuse. And tan is opposite upon adjacent. Opposite upon adjacent. You just remember it as this order you remember. Sin, cos, tan. Sin, cos, tan. You remember it as O, A, O. O, A, O. Like that you remember. O, A, O. That is, sin means opposite upon hypotenuse. Hypotenuse will remain the same, no? Cos means adjacent upon hypotenuse. And tan means opposite upon adjacent. Okay. O, A, O, A. Like that you remember. O, A, O, A. Okay. Don't laugh. Remember the trigonometric ratios this way. Okay, children. So now we are ready to take practice set 8.1. Yes. So let us take practice set 8.1. First question given. You have a right angle triangle here. As you can see, in the figure 8.12, angle R is right angle. So this is right angle. This is the acute angle. Angle R is right angle, 90-degree perpendicular sine I have shown. Write the following ratios. Okay, R is the right angle. So what is the hypotenuse? Frame the name of the hypotenuse in your mind. Hypotenuse is PQ. Hypotenuse is PQ. Fine. Now write the following ratio. Sin P. Let us write the formula first. Solution. What is the formula? Sin P is equal to, sin means O, that is opposite side upon hypotenuse. Opposite side upon hypotenuse, sin P. Now we have to see where is angle P. Angle P is this angle. Angle P is opposite side. Is which side? Angle P is opposite. So look at the opposite direction. Opposite side is RQ. So sin P is equal to RQ upon, name of the hypotenuse is PQ. Over 1 mark. So sin P is equal to opposite side of angle P upon hypotenuse. Mention opposite side of angle P upon hypotenuse. P को देखो, उसका opposite is RQ. Hypotenuse is PQ. Okay, put it in a box. Highlight your answer. Fine. Now the second question is cos Q. Okay, cos Q. Write the formula. OA. A means adjacent side of angle Q upon adjacent side of angle Q upon hypotenuse. Adjacent side of angle Q upon hypotenuse, which is equal to, if Q, this is the angle Q, no? Angle Q's adjacent side, bajuwala. Hypotenuse, you will not take it as bajuwala side. Hypotenuse is not adjacent side, the other one. So the adjacent side is RQ. So adjacent side is RQ. Understanding, no children? Q. So first you will see where is angle Q? Angle Q is here. Angle Q's adjacent side is RQ upon hypotenuse is PQ. Hypotenuse will remain the same. So we got cos Q as RQ upon PQ. Put it in a box. Okay. Next question is, so this over. Next question is tan P. Tan P. For tan, the formula is opposite side of angle P upon adjacent side of angle P. Opposite side of angle P upon adjacent side of angle P. So the star here is P. Where is P? This is angle P. Angle P ka opposite is RQ. So write RQ. And for angle P, the adjacent side is PR. You will not take hypotenuse. So adjacent side is PR. So we got tan P is equal to RQ upon PR. Very easy, no children? Now the last one you try. Tan Q. Where is Q? Q is here. Tan Q means opposite side of angle Q upon adjacent side of angle Q. Opposite side of angle Q, write it. Tan Q is equal to, tan Q is asked, no? Tan Q is equal to opposite side of angle Q upon adjacent side of angle Q. Angle Q's opposite side, angle Q's opposite side is PR upon angle Q's adjacent is RQ. So the answer is PR upon RQ. Okay. So very easily and happily we solved first sum of practice set 8.1. Let us move on to the next sum. Coming to the second question, same way we have a right angle triangle here. X, Y, Z, angle Y is right angle, X, Y, Z is 90 degree mentioned, and A, B, C are the length of sides. Length of the sides they have denoted it as A, YZ is A, XZ is C, and YX or XY is B. Okay, in the earlier sum, the sides were not given any names. In this sum, they have given variables for the sides of the triangle. They have asked us few questions. Let us write down the answer. First question is sin x. So write first question sin x. Before this, you can just write once again the introduction. Triangle XYZ. Angle XYZ is equal to 90 degree. Just introduction, no? Something you can write. And you can directly start with the question because you don't get extra marks, but write it. Sin x, sin formula is opposite side of angle x upon hypotenuse. Opposite side of angle x upon hypotenuse. Opposite side of angle x is x. Opposite side is yz upon hypotenuse name will be xz. Xz is the hypotenuse, no? For this triangle, 90 degrees opposite one is called as the hypotenuse. So that will always be, hypotenuse will always be xz. So angle x, opposite is yz upon xz. Now look into the figure. They have given the length of YZ as, where is YZ? YZ is given as A upon XZ is given as C. So what is the correct ratio? Sin X is equal to A upon C. Write this ratio down. Highlight it. So simple. Similarly, I want you to try the next sum. Pause the video, you get the answer and then check. Okay, so did you write the formula? Tan Z is equal to opposite side of angle Z upon adjacent side of angle Z. Now where is angle Z? Angle Z is here. Angle Z's opposite side is XY, which is equal to XY upon angle Z's adjacent side, hypotenuse we are not going to take. So next adjacent side is YZ. YZ. So how much is that XY? XY is B. B upon how much is YZ? YZ is A. So the ratio tan Z is equal to B upon A. All this you have to write and write the final answer this way. Moving on to the third question. The third question is cos x. Similarly, get the answer. So what was the third question? The third question was cos x. How will you write? Cos x is equal to adjacent side of angle x upon hypotenuse. Adjacent side of angle x. So you will look for angle x. Angle x adjacent side is xy. So xy written upon hypotenuse. Hypotenuse is xz. So xy upon xz. Xy is given as B and xz is C. So B upon C. Similarly, fourth question was tan x. Formula for tan is opposite side of angle x upon adjacent side of angle x. Angle x opposite side. Angle x opposite side is yz. And adjacent side of angle x is xy. Adjacent side is xy. Yx is yz is A and xy is B. So we got the answer as tan x is equal to A upon B. Okay, so you all got the answer correctly. I hope so. Moving on to the third question. Going to the third sum. As you can see, we have triangle LMN. And angle LMN is given as 90 degree. Angle MLN is marked as 50. And the third angle is 40. Okay, so all given. Write the ratio, trigonometric ratio of sine 50. So we will write, as I told you, introduce triangle LMN, angle LMN is equal to 90 degree. We will start with the solution. First question is sine 50. So sine 50. For sine, the formula is opposite side of 50 degree angle to hypotenuse upon hypotenuse. Opposite side of 50 degree to hypotenuse. So which is the side opposite to 50 degree? 50 degree is here. Opposite is MN. So simple. Upon hypotenuse is LN. Over sine 50 is equal to MN upon LN. Question given is cos 50. Cos 50 you will write. Cos 50 degree is equal to, for cos it is adjacent side of angle 50, which is equal to adjacent side of 50 degree, 50 degrees adjacent is LM, LM upon hypotenuse, as we decided it is LN. Hypotenuse is LN. So cos 50 also you got. Next we have tan 40. Similarly get tan 40. Tan 40 will be opposite side of angle 40 to adjacent side. Angle 40's opposite side is LM. Angle 40's adjacent side is MN. So LM upon MN is tan 40. Do it. Next is cos 40. 40 is this. Cos means it will be adjacent side of angle 40, 40 degree upon hypotenuse. Angle 40 degrees adjacent side is MN upon hypotenuse is LN. Okay, so complete the third and the fourth sum this way. And highlight your answer. So two sums, remaining two sums please solve and get your answer. Moving on to the fourth question. The fourth question is, you have this figure. You have the triangle PRS and then they have given a altitude also. They have shown a 90 degree, that is a perpendicular from vertex P. Let us see. Angle PQR is equal to 90 degree. PQR, this is 90 degree, and PQS is also 90 degree as given in the question. PRQ is alpha. Where is alpha? PRQ angle is alpha. And QPS is theta. QPS is theta. So in short, we have two right angle triangles here, and with that we have to find the trigonometric ratios. Write the trigonometric ratios for sine alpha. Now take one by one. First one, sine alpha is equal to opposite side of alpha upon hypotenuse. So where is alpha? Here. Alpha's opposite side is PQ. So PQ upon hypotenuse. For alpha, the hypotenuse, that is for triangle PQR, the hypotenuse will be RP or PR. PQ upon PR. So sine alpha is PQ upon PR. Okay. Coming to the next one, cos alpha. After sine alpha, they are asking cos alpha. Cos alpha is equal to adjacent side of alpha upon hypotenuse, which is equal to, now alpha's adjacent side. Don't take this. This is hypotenuse. So adjacent side is RQ. RQ upon hypotenuse is PR. PR. So we got cos alpha as RQ upon PR. The third question, tan alpha. Tan alpha is equal to opposite side of alpha upon adjacent side. Tan alpha is equal to opposite side of alpha upon adjacent side of alpha. Alpha is here. Opposite side is PQ upon alpha's adjacent side is RQ. So it is PQ upon RQ, tan alpha. So all the trigonometric ratios, 3 we got for alpha. Angular measure alpha. Now we have the next set of questions. Sin theta, cos theta, tan theta. Theta is here, so you will apply it for this triangle PQS. What will be sin theta? Now here only I'll solve. Sin theta is equal to opposite side of theta upon hypotenuse. So theta is here. Theta's opposite side is QS upon adjacent side. For theta, the adjacent side, that is, this is the 90 degree. And if for this triangle PQS, the hypotenuse is PS. PS is the hypotenuse. Sin theta is equal to QS upon PS. After sin theta, we have cos theta. Write the formula. Cos theta is equal to adjacent side of theta upon hypotenuse. Adjacent side of theta upon hypotenuse. Theta is here. Its adjacent side is, theta's adjacent side. Two are there, but we will not take hypotenuse. So adjacent side is PQ upon hypotenuse name is PS. So cos theta is PQ upon PS. What will be tan theta? Tan theta is opposite side of angle theta upon adjacent side. This theta's opposite is QS and adjacent is PQ. So QS upon PQ. Okay children, so I hope this practice set was the easiest one. Just you have to remember the formula for sine, cos and tan, and then you can solve practice set 8.1 just as easy as it can be. We will meet with the next practice set. As I told you, please subscribe and click the bell icon so that you get the notification and you learn geometry very soon. See you in the next class. Till then, take care, my dear students, and bye.